There are two substitution systems in a process compose file, and they look similar enough that people mix them up. One runs when the file is read. The other runs when the process starts. Once you know which is which, a whole category of confusing bug goes away. Start with the simple part. Environment variables can be set globally for every process, or on a single process. Both are lists of name equals value strings. Process level wins over global. There's also a .env file, read automatically from the working directory. You can point at a different one or several, and you can turn it off completely. Individual processes can have their own env file too. Now the part that matters. When process compose reads your YAML file, before it parses anything, it does a text substitution pass. In that pass, a name in curly braces after a $sign gets replaced with a value from your .env file or from the environment process compose is running in. Nothing else exists yet. Your process level environment blocks have not been applied because there are no processes yet. So here's the trap. Two processes. Both set the same variable in their own environment block. The first one references it in curly braces. The second escapes the $sign by doubling it. Watch what they print. The braced one prints empty brackets. The escaped one prints the value. The first was substituted at load time, when the variable did not exist anywhere, so it became an empty string. The second was left alone and handed to the shell, which expanded it at runtime, when the process environment was in place. The rule in one line. Curly braces mean resolve this now, from the .env file and the shell that launched me. $signs mean leave it for the process to resolve later. A bare dollar with no braces is a different thing again, and it is the one that surprises people. The loader only ever looks for a $sign followed by an opening brace. A bare dollar with just a name after it is not a substitution as far as the loader is concerned, so it passes straight through. In the command field that works out fine because the shell expands it when the process starts. But command is the only field that goes through a shell. Put a bare dollar variable in a working directory or in an environment value, and nothing expands it. Not the loader, not the shell. You get the literal text and usually an error. Braced substitution supports defaults, which is genuinely useful for optional settings. If you want none of this, turn it off. Disable env expansion at the top level rereads the raw file, and everything reaches the shell exactly as you typed it. There's also a way to compute a value at startup instead of hardcoding it. Env commands is a map of variable names to shell commands. Each one runs once when the project starts, and its trimmed output becomes the value. Two constraints. The command has to finish inside 2 seconds, and it should print a single line. That's the environment system. The second system is Go templates, and it uses a different syntax on purpose. Double curly braces and a dot before the name. You define values under vars, globally or per process, and process level wins. Templates work in more places than the command. Working directory, log location, description, each environment entry, and inside probes, including the exec command and the HTTP path, host, scheme, and port. That last one enables a trick worth knowing. When you run several copies of a process, each one gets its replica number as a template variable. 2 copies of the same server can't share a port, so you build the port out of the replica number. Replica 0 gets 4040, replica 1 gets 4041, and the readiness probe follows along automatically. One escaping problem you'll meet eventually. If your command already contains double curly braces, and Docker's inspect format is the usual culprit, the template engine will try to interpret them. Wrap the literal in quotes inside a template expression, or turn templating off for that one process. Last topic. Splitting configuration across files. You can pass several files and they merge left to right. There's also a convention borrowed from Docker Compose, where an override file sitting next to your main one is picked up automatically. That's the usual way to keep personal tweaks out of the shared file. That last point catches people. Relative paths in an override file resolve against the base file's directory, not the override's own. And there's a second gotcha. Setting disable to false in an override does not reliably re-enable a process, because false goes zero value for a boolean and the merge can't tell it apart from unset. There's a string version of the field for exactly this case. You can also inherit. A file can extend another file, and a process can extend another process in the same project, which is the equivalent of the extend service feature in Docker Compose. One caveat: if file B extends file A, load only B. Passing both with two file flags fails. Finally, strict mode. Turn it on and unknown keys become fatal errors instead of warnings. Write command instead of command, and you get a clear failure with the process name and the bad key, rather than a process that quietly never runs. Dry run switches this on for you, which is why it belongs in your CI pipeline. Next video: namespaces for slicing a big project into parts, replicas for running several copies, and schedules for work that runs on a timer.